Hello everyone. Today we will discuss about the relationship between Young's modulus and bulk modulus. Firstly, we need to understand what is the meaning of this Young's modulus and bulk modulus. In case of the bulk modulus, here when a body is subjected to three mutually perpendicular stresses of equal intensities, then the ratio of direct stress to the volumetric strain is known as bulk modulus, and this bulk modulus is denoted by the term capital K, and mathematically we can write that the capital A is equal to stress upon volumetric strain. So here direct stress is denoted by the term sigma and volumetric strain is denoted by the term small e suffix V. And here we also need to know about the Poisson's ratio, that is, and this Poisson ratio is denoted by the term mu, or it can be write as 1 by m, that is lateral strain upon linear strain. And here what is Young's modulus? Now Young's modulus is nothing but the ratio of stress to the strain is known as Young's modulus. Here in the relation between Young's modulus and bulk modulus, we will consider a cube here which is subjected to three mutually perpendicular tensile stresses on equal intensities. Here this equal intensities means that the magnitude of the stress as well as the nature of stress is same. That's why the sigma x is equal to sigma y is equal to sigma z is equal to sigma. Now let's consider the force is acting towards the x direction. If the force is acting towards the x direction, then what will happen to this body? Along the x direction, this will get elongate, and in the both direction, that is sigma y and the sigma z, in both the direction the body will get compressed. So the equations becomes sigma suffix x upon capital E minus mu sigma by E minus mu sigma by E. So here this first sigma x by E is the strain along the x direction, whereas this other two, these are the lateral strain. Here this sigma x by E, because here the force is acting towards the x direction, so there will be a elongation, linear elongation. So the equation, we know that the linear strain is equal to sigma by capital E. So it's the equations become sigma x by E. Now here in both the direction, y as well as in the z direction, there will be a lateral deformation, that means lateral strain. So from the Poisson's law, we know that lateral strain, Poisson's ratio mu is equal to lateral strain by linear strain. So if we need to find the lateral strain, then the equations became mu times of the linear strain, and we have already formula for the linear strain, that is sigma by E. So the lateral strain will be mu times of the sigma by E. So in the z direction also it will be same. Now why is minus sign here? Because if we apply a force along the y direction, this along the x direction, sorry, so this along the x direction the body will get elongate, whereas y and z direction it will get compressed. That's why it's minus sign, and the equations becomes for strain in x direction is sigma by E 1 minus 2 mu. Let's consider it as equation 1. Likewise, when we apply a force along the y direction, then what will happen? Along the y direction, the body will get elongate, whereas along the x direction and the z direction it will get compressed. So same like before, this is the y direction, this is for the y direction, and this is for the x and the z directions. So the equations became this one, that is sigma by E 1 minus 2 mu. Let us consider as equation 2. Now same will happen in the z direction. So when we apply a force along the z direction, in the z direction it will get elongated, whereas in other both direction it will get compressed. So the equation becomes like this. So let's consider it as equation 3. Now we know that volumetric strain, that is E suffix B, is equal to total strain. Total strain means we have to add all the strain along the x, y and the z direction. So equation, we have to add all the equation, that is equation 1 was for the strain along the x direction, and equation 2 was for the y direction, and equation 3 was for the z direction. Then by adding all the equation, we get this volumetric strain is equal to 3 sigma upon E 1 minus 2 mu. Or we can also write that if we shift this E, capital E here, or this one will get down, then the equation becomes E is equal to 3 sigma by EV 1 minus 2 mu. Or we can also write that E is equal to 3K 1 minus 2 mu. Why is K here? K is the bulk modulus, and what was the formula of bulk modulus is direct stress upon volumetric strain. So sigma by EV. So this sigma by EV we can write as K. So that's why the equations becomes 3K 1 minus 2 mu. Thank you.